Hello everyone, and welcome to this video lesson about environmental health. Environmental health is simply the study of how the environment impacts health. Of course, then we need to know what the environment is. And for the purposes of this field of study, it's considered anything outside of humans. It can be man-made things, it can be natural things, so trees and air, but also buildings and roads would all be considered part of the environment. Let's look at a few known examples to help put this into context. For example, we know that the kind of housing that you live in can greatly impact health. Things like lead paint, radon gas in the basement, asbestos in the insulation or in the attic, mold, any kind of pests like cockroaches or ticks or fleas living in the house. But also things like how safe the neighborhood is, whether you feel comfortable walking for exercise outside your home, whether you can send the kids outside to play. Those would all be examples of how housing can impact your health. Another example would be water. We always think of water sanitation and having healthy drinking water, and that's a good point. But don't forget about recreational water too. This can help improve physical activity by allowing people to swim and water ski and canoe. It can also help with stress just by being outdoors. But if the water is contaminated in any way, it could also be a detriment to health by exposing people to heavy metals, bacteria, parasites, and so forth. Another well-known context would be schools. Children spend most of their waking hours on weekdays during the school year in those buildings, so we need to be thinking about things like water, again with the asbestos exposure, air quality, exposure to chemicals used during cleaning, and also things like exposure to possible infectious agents. So the school environment is very important for our pediatric population. There are, of course, multiple examples of all these ways environment can impact your health. So for more information, check out Table 19.2 in your textbook. It includes a long list, not exhaustive, but certainly with more detail than I've given here. Okay, now you have some context for what environmental health is. Let's look specifically at how a community nurse might complete a risk assessment. The first thing to know is that in environmental health, we talk about risk being the hazard plus the exposure. In other words, we need to have some sort of substance that will actually be dangerous to humans, and then some way that those humans will be exposed to that hazard. In some cases, we're not sure which substances are hazardous or not, but we'll talk more about that in a minute. For now, let's focus on the exposure. In environmental health, we often talk about the exposure pathway as the terminology. The exposure pathway contains 5 concepts. First, the source of the contamination. Second, the transport of the contaminant. Third, point of exposure. Fourth, the route of exposure. And lastly, the receptor population. Let's go over each of these one by one. We'll start at the source. The source of contamination can either be chemical, biologic, or radiologic. Chemical would be something like lead poisoning, arsenic poisoning, chlorine gas exposure. Biologic would be things like botulism or anthrax. And radiologic would be things like nuclear power plant or nuclear waste exposure. We also classified contaminants as coming from either point or non-point sources. A point source is a single main contributor to that contamination in the environment. So, for example, many power plants are known for their smokestacks, just belching smoke into the air continuously. Non-point sources are more diffuse, harder to identify a single source. So, in fact, Los Angeles, most of the air pollution comes from individual cars and brush fires. So there's no single source. It's just the thousands and thousands of tiny sources put together that create that brown, hazy smog that you can see as you're flying into the LA airport. A final classification is toxins versus carcinogens. Neither one of them is good for you. The main difference is that toxins cause an acute poisoning or toxicity, so you know the effects fairly quickly, versus a carcinogen, which simply causes cancer. So often it is more of a delayed reaction to the exposure, and it can be harder to track down what the original exposure was. The challenge here for environmental health workers is that we don't really know what's safe. For example, maybe you've heard recent discussion about PFAS. These are a chemical that has been recently identified as potentially unsafe, but we're not sure which ones are safe and which ones aren't safe. We're not sure where they come from and where they end up. We don't know what levels might be safe. Same with radon. There's been some discussion about where we should draw that level of a safe radon exposure. We're not sure. Another question we don't always have the answer is how long do they persist in the environment? So how long would coal smoke hang around in the air? How long will plastic hang around in our landfills? We really don't know the answer to these questions yet, so there's still a lot of research that needs to be done. Okay, now that we've talked about sources, let's move on to how these contaminants are transported through the environment. One of the first transport mediums that most people think of right away is water. Of course, there are a lot of different kinds of water that we come in contact with. There's groundwater, and this might be someone with a well, or this can also leach into rivers and streams and things. There's what we call surface water, and that is those ponds and rivers and lakes. And then, of course, there's the water inside your home, wherever that comes from, or, of course, schools, workplaces, any of those other buildings. Another big one is air. Again, we have outdoor air, but don't forget about indoor air quality as well and how important that is. Then we have soil. Now, there are lots of ways soil can transport contaminants, but usually we talk about surface soil, which is, of course, the soil right there on the surface of the earth. So people will come in contact with this maybe when they're gardening, playing in the yard, even just getting dirt on their shoes. Then there's what we call the subsurface. And this we consider more if we're thinking about buried toxic waste, or if there's been a long-standing seepage of chemicals down deep into the soil. And that's more of a long-term reservoir, and it can also contaminate the water source in the area. And finally, we talk about sediment, which is that really fine soil that can be transported from place to place, either through water or wind, so it can really spread contaminants over long distances. Finally, we have living things. So of course, plants and animals kind of covers everything. And I can give you some examples here. For plants, if you plant food in soil that's contaminated with heavy metals, the plants themselves will bring up those heavy metals, and then humans who eat those will then be exposed to those toxins. Same thing with animals. We know, for example, that someone who eats a large amount of fish in their diet is at a high risk for mercury poisoning because of the contamination of the fish themselves. If we're talking specifically about biologic agents, then we also need to mention vectors and fomites. Vectors are those living creatures that will carry a disease from person to person, like ticks carrying Lyme disease or mosquitoes carrying malaria. And fomites are inanimate objects that can carry that disease, like doorknobs during flu season. Again, those are specific to biologic agents, so we'll spend more time on those when we get to our communicable disease lesson. Okay, let's move on. Next, we have the point of exposure. It's fairly self-explanatory. It's simply where the humans contact the contaminant. This can be pretty much anywhere there are humans. So schools, homes, roads, breathing, traveling, and any other place you can think of. Then there's the route of exposure. The route of exposure is simply how the contaminant enters the human body. There are three main forms of exposure. The first is ingestion. So the person eats or drinks the contaminant somehow. If we go back to that example of plants and animals, that's a common form of ingestion. Or little kids are known for putting anything and everything into their mouth. So little kids ingest things like lead, unfortunately. It can also be water. So if there are any chemicals in your water, any biologic agents in your water, that would be considered ingestion. Next is inhalation. So anything you breathe in. Asbestos is a great example here of an inhaled carcinogen that we know leads to lung cancer. Another example would be coal miners who breathe in coal dust, or more recently it's the quartz dust that's causing severe lung toxicity for those workers. Finally, there's skin contact. Many strong chemicals are known to be very irritating to the skin, like pool chemicals or undiluted cleaning supplies can cause erosion of the skin. This also includes some of the more indirect sources. For example, UV rays could be considered a skin toxin here. Or if someone is exposed to any kind of radioactivity, just by sort of being in the proximity, it would sort of loosely fall under that skin contact category, even though we know, of course, it's going to impact the entire body and not just the skin. A vocab word here is bioavailability. This is a measure of how much of that toxin or carcinogen actually is absorbed by the human body after that exposure. So for example, let's use lead poisoning. If small children start chewing on a windowsill that has lead paint on it, they might break off large flakes of lead paint. However, those large flakes actually hang on to the lead within them, and they mostly just pass right through the child, so there's a low bioavailability. On the other hand, if that window is frequently opened and closed and opened and closed, it creates microscopic dust particles of lead, and then the child inadvertently ingests those microscopic particles, and there's a high bioavailability of the lead in that case. So the agent itself will influence the bioavailability, but the route of transport through the environment to the point of exposure will also influence that bioavailability. Okay, the last piece of the exposure pathway is the receptor population. Basically, we're asking, who is exposed? So sometimes this is as simple as defining the population that was actually exposed to the contaminant. For example, if there's a chemical spill, who's in that area? Or in Flint, Michigan, who was drinking the city water that had the lead in it? But sometimes we also need to ask, who is vulnerable? So using Flint, Michigan again, we know that lead exposure is not exactly healthy for anyone of any age, but it's particularly damaging to the neurological system of young children. So in the case of that lead contamination of the water, the children were the main focus as the population at the highest risk in that situation. Sometimes it might be older adults, sometimes it might be pregnant women, sometimes it might be only males or only females. So this receptor population is all about defining who we're concerned about with this exposure. When you put all 5 of those together, that is our complete exposure pathway. So let's look together at this picture from your textbook to get a better idea of how this works. You can see that we're following here this spill of some kind of oil or chemical from these drums. So this was our point source of our pollution, but it's actually going to be transported through the environment in several different ways. Some of it leaches into the soil, and we can see that it just sort of stays near the surface, might be taken up into plants, might actually enter the home. Some of it goes deeper and then is actually getting into the groundwater here. And again, might be brought up into the home, might impact plants and animals. Some of it might also be released into the air, so we would have an air pollution situation instead. Now, some contaminants will only take one of these pathways, but this diagram does demonstrate that many contaminants can be transported through the environment in many ways. You can also see that there are multiple exposure points. If somebody is right by that point source, then of course they'll be exposed then and there. But it might be years, decades later before the contaminant travels through the environment to get to other people who are exposed at a different point. This person to the left of the diagram may have been exposed via skin contact or inhalation. If anybody eats these foods here in the middle, this would be an ingestion contact. If they're breathing the air pollution, of course, that would be an inhalation contact. And if it's in the water and then getting into homes, again, that would be an ingestion contact. Since we don't know what this substance is here in the picture, it's hard for us to discuss specific populations who might be at risk or how long the contaminant will persist. But remember, those are important questions to ask about the exposure pathway. Okay, let's head back to our main point, which was about risk assessment. Another important aspect of risk assessment is specifically learning to do an exposure history. This is where we ask patients about any potential exposure they may have had at work, at home, in the community, every day, or even just once. Unfortunately, it is often overlooked. It's most often used if we have some kind of chronic condition or an unexplained illness. This is also very useful on the community level. If, for example, you have a single community with an extra high incidence of lung cancer, you might do an exposure history for the community as a whole, looking for any source of inhaled contamination. The most commonly known use of an exposure history is the Poison Control Center. And I'll give you their phone number right here, just in case you ever need it. It's easy to remember, 222-1222. And they are experts at asking all of the relevant information about what the exposure was and any symptoms. And in fact, even healthcare providers will often call poison control for advice. Another important function of the Poison Control Center is that they track exposures within the community. So they might, for example, see a sudden spike in toxicity due to laundry detergent and discover that it's because laundry detergent manufacturers have started producing colorful little pods instead of just a liquid poured from a bottle. Of course, that is a real live example. Other examples include changes in packaging that make it suddenly easier for children to open packages they shouldn't be into, or for confusing packaging that adults have a hard time following directions appropriately, and so forth. For a detailed list of questions to ask during an exposure history, you can check out Table 19.3 in your textbook. They have a complete listing of those questions for you. Okay, to recap, we're talking about environmental health. We started by talking about the impacts on health. Then we moved to risk assessment, specifically the exposure pathway, and then the exposure history. And now we'll be moving down to talk about interventions if there is an exposure. We can use the levels of prevention here to discuss different ways we might try to intervene. So of course there's primary prevention, where we try to limit the exposure in the first place. For primary prevention, we try to disrupt the pathway, the exposure pathway. Even if we can break one of the links, the whole pathway falls apart. So if we talk about a chemical spill, we could, of course, avoid the toxic chemical in the first place. We could avoid transmitting it through the environment. We could avoid exposing our population, and so on. Even a single disruption to that pathway is enough, but of course, ideally, we would like to completely remove the contaminant from the environment to avoid any future potential for exposure to our population. That's not always practical. I'll give you an example. In Lancaster County, Pennsylvania, most of the soil is heavily contaminated with lead from previous uses in factories in the area and, of course, leaching from lead paint on buildings in the area. This means that any playgrounds in the city are also contaminated with lead in the soil. In a perfect world, we'd like to remove the contaminated soil from Lancaster completely. But that, of course, comes with a lot of its own barriers. For example, where would you put the contaminated soil in order to keep it safe for other communities? How would you pay for such a massive undertaking? And who would bear the brunt of that financial expense? So instead, Lancaster used a different approach, and in any playgrounds in the city, instead of using mulch or even the little rubber pellets, every playground is actually covered by rubber mats that completely block any kind of soil exposure to the children. So in this case, the contaminant still exists, but we've broken the exposure pathway at that point of exposure. Okay, then of course we have our secondary prevention, which I'm sure you're aware by now is our screening for any kind of toxicity. Examples here include how we screen all children at 12 months for elevated blood levels of lead. Another great example is anyone in the hospital who works in the radiology department. They wear those little badges that monitor their radiation exposure from the X-ray equipment. If at any point their radiation exposure becomes too high, the badge alerts them and they know to remove themselves to a safe situation. Environmental health researchers will also randomly collect samples from certain areas of the population to check for a wide variety of contaminants, just to keep an eye on any of those levels and make sure there are no new problems cropping up and that any identified problems are either remaining stable or hopefully improving. Okay, of course, finally, we always have our tertiary prevention, which is all about managing any of those complications that have arisen from the exposure. So this might be as serious as hospitalizing someone on a ventilator because of an inhalation injury, or it might be as simple as washing your skin well with soap and water if you know you've been exposed to a corrosive chemical. The challenge here with interventions is that we are always part of a system, and we're not always very good at predicting how a change to one part of that system will affect the entire system. For example, the United States was experiencing significant health burden from malaria transmitted through mosquitoes in the environment. So they decided to spray with insecticide across huge portions of the country. What they did not realize was that the insecticide was toxic to birds and wiped out most of a generation of birds. If you'd like to read more about that, Rachel Carson's famous book, Silent Spring, is an excellent description of the entire problem. There are, of course, a lot of other examples of how we have tried one action and did not foresee the unintended consequences. So it's always about a balancing act and doing our best to predict those outcomes, but again, we're not always very good at that. To wrap up our lesson today, we'll take a few minutes to look at the history of environmental health, where the movement first started, and some of the challenges we're facing today. People first started to recognize the importance of environmental health when there were huge past problems with things like air pollution, water pollution, and the health of miners because of the coal dust or rock dust that they were breathing. In fact, the Thames River famously caught on fire, and then in 1970, the Cuyahoga River here in the US caught on fire again, and people started to realize that if your water was polluted enough to burn, it was probably not safe to be drinking it. In fact, the 60s and 70s were a major turning point for policy in the United States regarding environmental health. In 1970, the EPA was founded. That's the Environmental Protection Agency. So they turn 50 years old this year. Congratulations to them. We also saw the Clean Air Act passed through Congress. And then in 1972, we had its companion, the Clean Water Act. All of these set up some basic structures for helping to ensure that we keep our environment healthy for the population in the United States. But it's very difficult to get everybody to agree all at the same time and can often turn into a political fight. More recently, we've heard discussions about environmental justice, And this is the idea that everyone needs to bear the same burden of environmental health, regardless of race, age, gender, socioeconomic status. So it's a great idea. Unfortunately, it is not necessarily followed all the time. For example, in Arizona, New Mexico, the Navajo Indian Reservation is also the same site where uranium mining took place for decades. So when the United States government was doling out land for this reservation, they decided to give the Navajo tribe the land that nobody else wanted. And that problem exists today and still puts the Navajo Nation at an increased risk of a wide variety of cancers. We also often see disagreements between corporations and citizens. So, for example, citizens might be lobbying the government for tighter restrictions on the emissions from a local factory, where the factory will be resisting that change because of the financial cost associated with it. So then we get into discussions of who should pay for the changes and whose needs outweigh the others. And so we get back into the politics, and we end up as nurses needing to remember that one of our roles is to advocate on behalf of our client. And in this case, the entire community may be our client. Most of the problems we know about today have been identified through something called environmental epidemiology. Epidemiology is the study of where and when diseases appear. So for environmental epidemiology, it's specifically looking for clusters of illness or a change in rates of illness. Early examples include public health officials realizing that children who worked in factories all day did not have enough sunlight in their environment and were developing rickets, or realizing that most miners who worked in the coal mines were dying of lung disease. What often happens with environmental epidemiology is that the researcher notices a spike in the rate of disease in a single population and then has to go searching for that underlying cause. We often don't know that underlying cause right away. If we bring these historical examples back up to our impacts of health, we get to some real-world examples of these impacts today. An important one is climate change. We know that climate change impacts our environment in many ways, but I'll give you a few examples here. Heat waves. Older adults are especially at risk during heat waves, but the entire environment suffers if there's this prolonged period of higher heat than common. We also see an increase of floods, which of course directly impacts water quality, housing quality, and so on. Of course, the other side of that equation is that some areas of the world are seeing drought, so they don't have the water that they need to grow food or to maintain hygiene, or we see huge amounts of dust in the air affecting air quality. Food supply is often interrupted by climate change because of erratic growing seasons. For example, if it's 60 degrees in February and all of the plants start to grow and bud, and then we enter another solid freeze, all that new growth is killed off, and the plants have to try to struggle to come back when spring truly arrives. That change in temperature can also allow for an expanding habitat for vectors. So we see things like Lyme disease becoming more prevalent as ticks fail to die off over the winter. Or malaria could start to spread across more of the globe if we don't have those cold snaps to maintain the mosquito population. In addition to climate change, any other disaster plays a direct role on environmental health. These can be man-made disasters or natural disasters. For example, earthquakes. In addition to just causing outright destruction to housing and waterways and things like that, you can think of the 2011 Fukushima earthquake. It was actually March 11th, so we're right here at the anniversary. That earthquake also disrupted the reactors in the nuclear power plant, so there was a massive radiation exposure through the community. Any kind of explosion can force a contaminant into the air, into the water system, and explosions often travel for miles with that contamination. More recently, we're hearing more and more about pipelines leaking or catching on fire or exploding. Or we've also, of course, historically had many oil spills, either from oil wells in the ocean or oil tankers that have leaked. And then finally, from recent events, we've heard a lot about wildfires. Wildfires, of course, directly destroy vegetation and animal life, and unfortunately often human life in their path. But there's also a huge impact on air quality, which then also affects weather patterns for miles and miles and miles around. So even though these on the surface appear to be a single isolated disaster, we know the entire environment for many thousands of miles surrounding that single location can be directly impacted. Okay, that wraps us up for environmental health. Let's look at the whole picture one more time. We talked about how environmental health is the environment impacting human health and how that can happen in a variety of environments, whether they're large environments such as planet Earth or little microenvironments like the inside of your house. We also talked about risk assessment, including the exposure pathway and taking an exposure history, then the different levels of intervention for any kind of exposure, and then a little bit of context, history, and current events for environmental health here in the United States. For more learning activities, check out Canvas, and as always, send me an email or give me a call if you have any questions.